All right, let me try and give some justification as to why we're going through the process of even creating two histograms for one random variable. So here I've got actually three histograms, but I'm giving three to kind of demonstrate something. So let's say the two histograms you made, one with a low number of classes was this one, okay, a histogram with 6 classes. And the second one you made was with a higher number of classes, or 10. Now, the first one you made uh, looks quite nice. It looks like we've got a single mode, one central class that's the highest, and all the others are kind of falling away from it. Looks really nice. But then you'll notice as we increase the number of classes, so if we go from 6 to 7, okay, that single mode, that single class that was highest, actually starts to split into two classes with an equal frequency. So instead of having one mode, now we've got two modes. And when we go to a higher number of classes, in this case 10, those two modes actually split apart and become two distinct classes with equal frequencies, but are now split apart. This seems to indicate that we don't really, truthfully, have a single maximum here. We don't have a single mode. We actually have two modes in our data. So if you were to choose this histogram to represent your data, this would be misleading. And this one would be more truthful to the data that you've collected. If you created this histogram, or let's just say whether you created it or not, let's say this was the true nature of your data. This is the true nature of your data. And you didn't go through the process of even making this in the first place. And you only created this histogram and you published this. You used it as a justification for your work or to make your point. This would be misleading. This would be false. Okay. So this is where you need to do your due diligence and try and discover the true nature of your data. And one of the ways that you try and determine the true nature of your data is by creating multiple histograms with a high number of classes and a low number of classes. This is to help you develop the strongest possible argument that you can make that's truthful to the data that you've got. By contrast, let's look at another example, again with a low number of classes and a high number of classes. And just like I pointed out before, with a low number of classes, we have one class which seems to have the highest frequency. So we have a single mode. When we increase the number of classes, again, we have a single mode. And when we have the highest number of classes, again, we have a single mode. So no matter how many classes we have, the data still seems to indicate we have a single mode here. And so, it would actually be not much of a difference, perhaps, to choose any one of these three to represent your data. But you would only know that by creating multiple histograms. And I'm not asking you to make three, to make this intermediate one. Just create one with a low number of classes, create one with a high number of classes, and see if there's any funny business going on. See whether those two histograms appear to be consistent. Okay. Contrast to what we had just now, where we had one mode break up into two distinct modes. Okay, we'd want to know that. But in this case, our single mode stayed a single mode regardless of how many classes we chose. And so any one of these three histograms would be okay. However, the one thing that I'd want to point out that would influence, which of these three you would want to choose is look at the midpoint for mode. Look at the midpoint for this class, the midpoint for this class. The midpoint of the class that has the highest number of frequencies, this is going to have your mode. And we're going to learn about mode and measures of center. And so what you'll notice is that, the midpoint here was 132.5. But as soon as we increased the number of classes up to 12 and 16, that midpoint changed from 132.5 to 122.5, and then changed again to 121.5. So notice that these two values, 122.5 and 121.5, these are pretty close together. Whereas 132.5 and 122.5, these are quite different. Okay, this is a difference of 10. Whereas over here, we have a difference of only 1. So what this is kind of indicating to me is that even though each of these are showing a single mode, that single mode appears to be closer to the low 120s than it is to the low 130s. So the more ideal histogram that I would choose would either be this one or this one. Okay. And all of this that I've just verbally described is the same thing that I'm saying over here with text. All right. So from now on, even when you're outside the statistics class, you're in the professional world, you're in academia, and you're creating histograms, these are the kinds of things that you want to keep in mind. And for your student projects, when you're creating histograms of your data, you want to be able to find these things and point these things out. And that's why designing histograms is so important and why we're spending so much time on this. Let me know if you have any questions.